we'll get into some more required theory and little in depth into SOA administration. Then if still we have enough time, we will get into the installation today. So I'll be covering yesterday we have seen the introduction. It's more like what is SOA, why we need SOA, and what SOA provides. So we will today see how SOA provides that. And so whatever we've seen it provides, yes, it provides these two, especially the agility, the flexibility it provides, and it provides the reusability. So it allows your existing softwares to be used. And the second thing we said is it provides agility. So we will see how it provides it today. Means we are actually getting into the what we say the structure of SOA, Oracle SOA architecture, more of means the internal components today. So now we know why we are using SOA. After yesterday's session, we know why as a business we want to use SOA. Now we are looking from a technical perspective. We are the administrators. So if we are the administrators, what kind of technical implementation we will have to achieve or to give what the business is looking for. Alright, so these are the two things that we talked yesterday. It allows the reuse of the existing softwares. Alright, it uses adapters to allow such a usage. Using an adapter, it converts every software into a service. The second thing, it gives or it uses what is called a BPEL language, Business Process Execution Language. Using a BPEL process language, you will be able to define a business process. So we will see how a BPEL program would look like, or how a developer writes a BPEL program. We're not really going to develop a program, but it's good to know how a developer would look at this entire thing. It's really important that you have an overall view, otherwise you will still feel fuzziness. So that fuzziness should not be there. So on the right side you have yesterday's. This is the same diagram that we've seen yesterday. This is a series of softwares probably eBay is having on the right side. Now follow the cursor on my screen. The hand you are looking at is this group of softwares with the independent flow. Each of them has an adapter here. This adapter will be on our SOA infrastructure. As an administrator, you will be installing this adapter. You will be configuring these adapters. Then, once this adapter is installed, each of these services is exposed as a web service. The moment it's exposed as a web service, you can talk to it using XML. That's one part, reusability. The flexibility or business way of defining something is provided by what is called a composite. Composite is like what is an application, Java application for WebLogic is a composite for if you are using SOA. So if you are having only WebLogic, so far, so all of you who have been working on WebLogic, normally you will be given a jar file or a var file which is Java code. Basically it can be servlets, JSPs or EJBs, Spring, Hibernate. Any of the Java code is basically a JEE application. Now as opposed to, so a JEE application goes on WebLogic, whereas a BPEL application is bundled into a SCA component. We will see what is SCA. It's called Service Connector Architecture. We'll see those things. Then it's also called a composite. We don't call it an application anymore. In SOA, what you get from developer is called a composite. Now the components means the elements of a composite can be any of these 4 or 5 things that we're going to talk today. What a BPEL component is, what a mediator component, what a human workflow component, and why they are used. So we will see all those things. Later we will get into EDN. What is EDN? Event Delivery Network. This is one of the main differentiators between other GMS or other SOA systems and Oracle SOA. The EDN basically gives the ability for the application not to worry about the GMS related stuff. So I'll talk about those things in detail later. It gets confusing at this point. So we will be concentrating more on this part today. Means the application. What type of application will be there? What type of application will be there, or what type of application gets developed if it is SOA? We try to compare it with the regular Java application that you've been doing all this time, and then we will get into the installation. Alright, then again, to execute this application you have engines. BPEL engine is one that executes BPEL code. So remember, here there is a slight, you will always have a slight confusion. There is a component BPEL, there is a language BPEL. Remember here, BPEL is a component, business process execution language component. That's one component, whereas all these components are written in BPEL language also. So the name is used as a synonym in most of the cases, but we will see what the component is basically one element, whereas BPEL is a generic programming language that we use. We'll get in there. So we're trying to look at individual components inside SOA. Mainly there are 5 components. The one is the BPEL, business process execution language for process orchestration. The component of SOA is actually BPEL process manager, it's called. BPEL is a language, and to execute the language there is a manager, process manager. So the first of these 5 components is BPEL process manager. BPEL PM, that's what it's usually called. Now the process manager will execute a process end to end. You'll see in depth into those things later. Then there is a mediator component which is used for routing. Routing is, should I choose service 1 or should I choose service 2? That's routing. Now the decision will be based on a routing rule. A rule says if the value of X is 1, choose service 1. If the value of X is 2, choose service 2. So that's what the mediator does. The mediator redirects the request from one service to another service depending on the values of certain variables. Then human workflow is a third component that a SOA developer uses inside a composite. A human workflow is inserted into a composite if we require some kind of approvals. Let's say you're for example, you are submitting a loan application. If you are submitting a loan application, a certain amount, let's say you are asking for a small amount, probably it goes through an automated process. If you have submitted all the documents properly, the system itself will verify all the documents, you will be sent across. But if you are asking for a very large amount, let's say you are asking for 1 crore rupees. Now when you are asking for 1 crore rupees, usually a manual validation probably is required sometimes, just to make sure the systems don't make mistake and they don't give you all the money to the wrong person. So what this is, there may be kind of a manual intervention required or a manual approval required, which means a request has to be sent to one of the managers. The manager will open some kind of GUI or a browser based application. In the browser based application he will see the request. Once they see the request, they approve it. If they approve, the process will continue further. So we are introducing a human workflow element in the process execution. It's like reading a value when you're executing a program, a C program or a Java program. Let's say you are reading a value. Now if you are reading a value, somebody has to enter that value. But whereas in SOA, it is much more uh, refined or much more advanced level. So you can actually assign it to people, you can send notifications, you can delegate later. Those things can be done. I'll say in depth again. Business rules and decision services are another component that will be especially used by the first two. BPEL and mediator use the fourth element, business rules and decision services, to execute a process end to end. Now, Spring context is something embedding a Java program inside a composite. Now, as we know, composite is not a Java program. Composite is more like, it looks like XML code. So whereas Spring context is more of a Java program. So we are taking a Java program, putting again inside a composite. Now, to give you a better understanding of what we've been talking about, I'll show you some screenshots of some real-time process. Look at these things. Adapters. No, not adapters. We are talking about the BPEL process. BPEL process or mediator process. Seriously. If you see, this is a airline's ticket reservation. Now there is an application. This is a BPEL process we are looking at. Means if you are a developer and you are writing a BPEL process, this is how it would look like. The box that you are looking at is the BPEL process. This one. Alright. Follow the cursor on the screen. I will always talk about the cursor usually. So here if you see example BPEL process for the business travel. So what this does is it books a ticket that costs you less. That's the BPEL process that's supposed to do. So it will either book you American Airlines ticket or it will book you Delta Airlines ticket. Both these American Airlines company, Delta Airlines company, they have what is called a web service exposed on their website or on their servers, which can be called to find out the status or to find out the value or the price of a ticket. Now let's say you have started a website. Now your website looks something like this. A customer can come to your website, alright, they can give the source and destination. Your website will go to all the available airlines. It's just like my Make My Trip or any of these websites. What these websites do, they are not the airlines by themselves. They go to all the airline providers services. They go to Air India, they go to SpiceJet, they go to Kingfisher if it is still there, then they go to Indigo, then they go to all other. Let me give you Make My Trip. You are traveling from Hyderabad. Traveling from Hyderabad to Delhi. Right? So you go to search for the flights. Just search. Now this software might be BPEL. Let's say it's implementing BPEL. So what it does is it queried the SpiceJet web service, it queried the Indigo Nation web service, it queried Air India website, it queried couple of other Jet Connect, and it got the prices. It got the prices from those websites. Then it compared those prices at second level. See this thing. Look at this first thing. Invoke retrieve the employee travel status. First thing, if you are let's say you are booking tickets for your own employee, If you are a company employee and we are basically the travel department books the tickets for all of us. So when the travel department books the ticket, we usually have various bands. Probably a vice president can go in business class in some of the companies. A CEO can go in business class, whereas the regular, like us, we go most of the times in economy class. So that's the travel status of the employee. Once the travel status is invoked, now look at the second stage here. It get plane ticket offer from American Airlines, get plane ticket offer from Delta Airlines. Basically, it is making a request to American Airlines. It invokes, it gets a response. The same way it invokes Delta Airlines web service, gets a response. Once it got the response, it made a comparison. Look at this one. American price is less than Delta price, then select the American Airlines ticket. If American price is more than or greater than Delta price, select the Delta ticket. Right? Now once one of the tickets is selected, alright, return the best offer. So what this people process is doing is, it is checking the status of the employee first, then it's calling the services, it's giving you the best offer at the end of this one. Now this entire thing is written by a developer. Now this entire thing is called a people process. Somebody can call this people process like we did on this one. Let's say we called a people process. What is the response we got? We got an ordered list of prices available. Alright, so that's what our Make My Trip service has responded with. So we are here, the client. This is what we are on the Make My Trip website. We made a request with the inputs source and destination. The people process of Make My Trip executed all these steps. While it is executing, it might have called certain external services like these three. At the end, it returned us the output. Now this entire thing what we have seen is happening on a website where there is an interface. If the same thing happens using XML, means you send an XML input, you get an XML response. That is more like what happens in web services. So internally what the interface would have done is it would have sent, taken that input source and destination you have given, converted into an XML file, and the request was sent here in XML to the Beeple. So this is the Beeple. The Beeple did all the thing. Beeple again sent back the response. Our client, again the Make My Trip client, processed the XML response, displayed it in the form that we want. Alright, this is one of the real-time examples. Let's look at one more. This is a much more complicated one. Application status. You can create an application, you can submit an application. This is interview selection basically. You create an application first, then you submit the application, somebody reviews it here, either you schedule an interview or reject it here. If you schedule an interview, you will have to be interviewed. Let's say you got interviewed here. After the interview, alright, you were given an offer letter. If you are interested and you join, you are hired. So this is the end-to-end process again. A similar thing. Let's not go in depth into it, that will be waste. This is another Beeple process. So if you see, we're talking more in terms of not technology, in terms of flowcharts. That's what we are talking, and that's what SOA gives you the ability. You're not talking in Java, you're not talking in C anymore. You're talking in, let's call some service X, which gives us the ticket prices. Let's call some service Y, which gives us the employee travel status, like that. The same diagram again in a different way here. You submit an application. Once it is submitted, it gets reviewed. Alright, after it gets reviewed, you get interviewed. After you are through with the interview, you will be offered. If you are offered uh, you know a job, you accept it, then finally you hire it. So this is another flowchart that could be converted into a paper, a business. So this is more, it sounds more like the way the business is done. So if you ask the HR manager, that's what he would talk about. Let's ask the participants, or let's ask um, you know the people to submit their application. We will review it, then we will interview it. If they are selected, we will offer them a offer letter, and if they are okay with it, we will accept it, and they accept it, and we'll hire them. This is the language of a business people. This is not the language of a technical people. Now the same flow can be directly implemented using BPEL, business process execution language, and there are tools to do that. We will see those things. Alright, so SOA allows easy implementation. SOA allows business type of implementation with a lot of technology going behind the curtains. You don't have to directly deal with the technology. And this is another application, kind of bank application. You create an app. I'll send you all these images. You can leisurely go through. This is another process flow, again, that can be converted into paper. Now in this, probably you will have a mediator also. See this one, request offer. If you see here, sorry, something went wrong. Oops. Yeah, this is the one. If you see, there is a request offer here. The request offer has two options. If it is rejected, there is one flow. If it is accepted, then there is one flow. Now, depending on the value, the mediator will route it to the corresponding service here. So inside a BPEL, you may have a mediator component. The same way, if at any of these stages, if it has to be approved by, let's say we apply for leaves, you all of us apply for leaves. Let's say the leave process is automated in some of the companies. We officially, we obviously send a mail to our manager. Once that is approved, then we will actually put it onto the system for official records for tracking. Now during that system, you apply for a leave, the manager has to approve it. Now if the manager does not approve it, it usually goes to the next level. That's an automated process. Now that can be implemented using what is called a human workflow. So you apply, so the request will go to the manager, the manager approves it, finally the request gets closed. That can be implemented using a SOA based human workflow. Alright, these are some of the examples, real-time examples of implementing SOA. Let's go back. So the 5 components internally, depending on the requirement, you may use some of them, you may use all of them. So the flowcharts are the business scenarios where we try to execute a process. One of the process we have seen, the best one at the beginning, is book a ticket for me or give me the list of best prices. So somebody called the service, a BPEL was executed, BPEL in turn called certain other airline services to fetch the availability and to fetch the prices. Then BPEL processed those prices, presented to you in a format, the front-end application presented to you in the format. Now remember one thing, entire SOA communication is in XML, so you won't find any interfaces. Even on Make My Trip, the interface that we have seen, it's not related to SOA. SOA has given the response in XML only. There is another application which actually formatted the XML and then presented to you. So all SOA communication is in XML, the request and response. Alright, so let's go into these are the components of SYA just now we have discussed. So BPEL is the language in which all these things are written. The process manager is the one that actually executes a BPEL type of means. A process manager is usually, you will come across a term called orchestration. If you observe this diagram here, so I will practice this one. This is a process that needs to be executed end to end. So this one from this point means we have to invoke the employee travel status service and then wait for the response from the travel status web service here. Then there has to be a comparison. Again, we are actually calling two services in the second layer here. We are calling American Airlines web service, wait for the American Airlines web service to respond. Then we are calling Delta Airlines web service, wait for the Delta Airlines web service to respond. Now, who is going to take this process from this stage to this stage? Wait till both of these are executed, then take it to this stage, then take it to this stage. When somebody has to coordinate this entire flow, that's really important. Now, the central element is the process manager we are looking at. So the process manager is the guy who is, he's like, let's say, if you are organizing a function, there are a lot of things you have to do in function. Order catering services, invite people, receive people, or see if there are enough, everything, lightings, everything is there. So a function has a lot of, it calls up a lot of services. There is one guy, probably the event manager, who coordinates this entire event. Now here the event manager is the BPEL process manager. The BPEL process manager calls the external services, in this case the employee travel status, American Airlines, Delta Airlines. Once the response is received, the process manager will take the entire BPEL process to the next level. Now this method of calling the external services, taking your BPEL process from one stage to another stage, is called orchestration. Orchestration, ORCHESTRATION. Now you will come across this word somewhere or the other, orchestration is listed. Not, this is more a generic SOA word, but Oracle SOA you might come across, or you may read this way somewhere. Orchestration actually comes from, it's a music word, and actually SOA uses that word. So if you see, did you see one of these music concerts? If Rahman is playing, there are 10 guys behind him with violins. All of you are, you can imagine that scene, right? Let's say Rahman gives a live performance, or he is giving a orchestra, not the regular orchestra, not the orchestra that we know, especially in Andhra, not that part. The Nasrapet style orchestra. We're not talking about that. We're talking about a proper musical orchestra. In a proper musical orchestra, there is one guy, who keeps moving around his hands. That's right. Who will move the hand and stand in the middle? That guy is called is the main guy. Everybody else actually follow that guy. So the guy who is standing in the middle, waving his hands, is controlling everybody's flow. And the process of controlling from a centralized point is called orchestration. And that's the reason it's called an orchestra. Alright. Now, as opposed to orchestration, means a process can be centrally controlled and can be executed end to end, which we are seeing at this point. Here, the BPEL process manager will start here. It will call the services. It will coordinate the responses from the services. It will take the BPEL process towards the end of the flow. That's orchestration. As opposed to orchestration, there is another form of process execution called choreography. just like our movie choreography. The movie choreography, there is a hero and on the backdrop you have dancers. Alright, the dancers, all of them will follow the same steps just like your hero. Alright, now is there a central coordinator when it is actually being performed, or each of them will perform individually? They try to do the same way. Is there any central coordinator when you are performing a dance? In regular Hollywood, Bollywood, Telugu movie stuff, there is a hero, there are background dancers. Is anybody controlling? The practice is different. They will practice all the time so that it's in sync. So but there is nobody who actually controls the moment. So each of them is supposed to individually perform their movements. Nobody is guiding them. That is called choreography. So there are certain softwares which will implement a choreographed style of process execution also, whereas the Oracle SOA that we are studying implements an orchestration style of process execution. So if you are looking at this flow chart, we are trying to execute this flow chart in an orchestrated style. And who does the orchestration? Who the event manager is basically the BPEL process manager here, and the language itself is BPEL. Alright, so in all SOA you implement orchestration, but for theoretical purposes, for your knowledge, there is another form of process execution called choreography also. Now if you get time, just go to Wikipedia and just have a look at it. Orchestration versus choreography, it's very nicely explained. Orchestration, there is a centralized coordinator. Choreography, there is no centralized coordinator. Each component tries to execute a process independently. Alright. Now, so the BPEL process that we are talking here, BPEL process manager is the guy who orchestrates the process execution or the flow chart that you are looking at from end to end. Now within that, that's called again the execution box that we have seen, it's called a composite. This box that will be put into a composite by the developer, and it will be converted into a jar file and will be given to us. As an administrator, we will actually deploy the jar file, but what is inside the jar file? The code related to executing this flowchart, and the entire code is in XML. Alright, we'll go into that part also. And apart from a BPEL process manager, you might have mediator whenever there is routing required. Whenever there is human intervention required, you might have human workflow. The BPEL process manager and mediator might require certain decisions to make. Means a value of X, I said, okay, I'll come there later. Then Spring business decision services is what makes a decision, but for the decision service to make a decision, it uses business rules. Business rules are what are defined by the business users. They will let's say give discount of 10% if the price is, if the purchase, let's say you go to Big Bazaar. If you go to Big Bazaar, they will give you a gift voucher if you purchase more than 2000. That's a business rule. Business rule says if the purchase is more than 2000, give a discount of 10%. If the purchase is more than 5000, give a discount of 15%. So business rules are these two rules. And what is the decision service doing? The decision service actually checks your purchase value. What is the purchase value? Is it, let's say your purchase value is 2000. Sorry, 3000. If the purchase value is 3000, the decision service decides about the discount. What should be the discount if the purchase is 3000? I'm just asking a very simple question so that I know that you understood. These are the two business rules we are talking about. If purchase, alright, greater than 2000 or less greater than 2000, let's say, then discount 10%. That's rule 1. The rule 2 says if purchase between 2000 and 5000, 2,000 and 5,000, discount is 15%. Now somebody made a purchase of 3,000. Alright. Now the decision service makes a decision about the discount. Now for the decision service to make a decision about the discount, it has to know the business rules. So now you understood the relationship between business rules and decision service. So decision service requires business rules. So decision service requires business rules so that it can make a decision. So now the discount is 15%. Let's say 10% or 15%. Now discount is made. If purchase is between 2,000 and 5,000, discount is 15%. We are saying. Let's say somebody made a purchase of 3,000. So obviously he will fall. The rule 2 will be applied. 15% discount will be given. So discount. Now discount amount the decision service made is going to be somewhere around, let's say 300 plus 150, 450 rupees. That's 15% of 3,000. Now a mediator can use this one. Now how a mediator is going to use? If discount, let's say if discount is greater than 300, then call service 1. If discount is less than 300, then call service 2. So the mediator is doing a routing. But for the mediator to see this one, see the flow here. Mediator wanted to do something here. What it wanted to do? It wanted to either call service 1 or service 2. But to do that one, it wants to know the value of the discount. The mediator itself is not counting the discount value. The discount value is calculated by a decision service. So the mediator calls the decision service here. The decision service is expected to give the discount amount. How the decision service makes the decision? It does not know how to make decisions. It depends on certain rules defined by the user. The user defines a couple of rules. Now the decision service uses these rules to give the final amount. Once the final amount is given, the mediator is routing. Now see the reason why we have to divide it so many times without hard coding is these rules can be changed at runtime. That's the most important thing about this entire flow. Now why not hard code the discount amount? You might ask me that one. Alright, if I hard code the discount amount in the code itself, then I cannot change these rules tomorrow. If Big Bazaar wants to change these values, let's say to 12% and 17% tomorrow, then I'll have problem if I hard code it. I want to give the business the flexibility to change things at runtime. So there will be an interface to change these rules. So the Big Bazaar business owner manager, store owner will be given an interface, nice interface with a browser where he can define these rules. Just define the rules and our entire billing system will change automatically, because these are all individual components. The mediator will call the decision services. Decision services makes the decision depending on the rules. Alright, that's how they are related to each other. So business rules and decision services are all, they both are related to each other. Then the spring context is the next element in your entire SYA. I just given whatever explanation I have given, I put it into that the PPT you are looking at. As I said, BPEL is a language and BPEL process manager is the orchestration, the event manager. So there's a slight difference between these two. BPEL is a language that all these components are written in. I'll show you a small video of how a developer actually works. All these elements are components of SOA are written in BPEL, Business Process Execution Language. Then apart from BPEL, there is another component called Process Manager, who is the event manager. He orchestrates the entire flow. No, there is no choreography in Oracle SOA. And EDN is not for choreography. EDN is uh, it's not for process execution. EDN is basically for event management. Means how do you publish events, how do you subscribe events, all that stuff. Yeah, Vamshi, I think you guys cannot see the question. The question asked by Vamshi was this one. I just posted it on the chat. Any questions, please post it to the entire audience so that my answer is relevant to everybody. So Vamshi is asking here, do we accomplish choreography in SOA through EDN? No. Answer is no. EDN is not for process execution. Choreography is a way to execute a process, just like orchestration. So EDN is not the one that actually does it. That's answer for now. Now, as we move into EDN later chapters, you will have a better idea. But for now, just understand the difference between choreography and orchestration. And choreography is not used in Oracle SOA. Remember that one. In Oracle SOA that you will be working on, you will never use choreography. Oracle SOA does not support choreography. It's orchestration, and the orchestration is performed by the BPL process manager. Alright, then again, the BPL is a programming language, a process execution language in which all your SOA applications are developed. So your SOA developer, if there is anybody, they will be working on the BPL, just like a Java developer works on Java. This is one of the diagrams that I have already explained to you, a ticket booking. Alright, then the second component I was talking about is a mediator. Now, if you look at mediator component, the main purpose of a mediator is to route. Routing is if value discount. I think we have just now seen one of the routing examples. If discount is 300, route it to service 1. Sorry, this is service, not server. If discount is less than 300, then call service 2. So that's the routing. The mediator is routing. Apart from routing, even though routing is the most important thing that mediator does, there are certain other things that a mediator performs. It validates. Validation means if the incoming XML input, is it in the required format or not. Let's say input requires to be an integer. If somebody sends a floating number, then the input will be rejected. That's a validation. Then enriching, the E part of Vedro. Enriching is, let's say the calling service has provided only 2 fields, but what we are the external right side service here, let's say in this case, the mediator got only 1 input, but this service, as service 1, requires 2 inputs. Something like country code, which is already available in the context. So the mediator will simply enrich the message, add the additional fields, call the service, even though the client who is invoking or requesting did not provide that kind of field. That's enriching. Transforming. This is an example here. Transform a comma delimited file into a database table structure. That can be done by a mediator. You give a file, let's say with values, a comma separated value, something like this. Let's say employee name and employee number. You give employee number, let's say name, alright, like this. You give a number and a name. Now if you give this file a comma separated list to the mediator can transform it and convert into an SQL query, execute the SQL query in the database so that a table gets created with these values, or if the table is already existing, it gets inserted. Then routing, we already seen. Operate the backend service. Obviously here, if mediator is calling this service 1, it should be able to send XML input to this service. The mediator should be able to process the XML response that is received from this service, which means basically the mediator can or should be able to operate the called service. Means send a request, process the response. That's the last element of mediator. So mediator performs these 5 functions. The same 5 functions are applicable for OSB also, Oracle Service Bus. Mediator and OSB are same. Only thing is, mediator is inside a composite. OSB is completely outside SOA. Both are actually used for routing. OSB provides more services than mediator. We will see that during OSB later. But both of them are for VETRO. Validate, enrich, transform, route, and operate. Remember these VETRO things. This is one of the examples. This is an XML file input. The XML input is, let's say, coming from a HTTP transport layer protocol. We'll talk about SOAP HTTP in a few minutes. Then it validates the input at this stage, enriches it, means it added an additional box here probably, transforms it, alright, a comma separated list unit database structure, route it to the backend, and operate, or talk with the backend, process the response. So these are the VETRO properties offered by the mediator. This is another example of how a JDeveloper screenshot would look like. If you are a developer of SOA, this is what you will be working on. Look at here. You went into something like a flipkart.com. You make a purchase, alright? If you make a purchase, you made a purchase here. The mediator is supposed to call service 1 if it is within India, which is inland shipping. The mediator has to call a overseas shipping if it's outside India. So this box is the mediator box, and this entire flow is the BPEL flow. And you are the developer, you will be dragging and dropping these boxes. You double click on this arrow mark here, it will allow you to configure the properties. So this, now we will see a video also about this entire development stuff. This is a mediator, how the developer looks at it. The third element in the SOA components is human workflow. Alright, human workflow is basically, as I told you, it's for inducting or a human interaction. It's like reading an input from a user if you are executing a process. It basically used for interaction, process with human interaction. Now the examples here are approvals, exception management. Like say if something goes wrong, what you want to do. Either you want to discard the exception, or you want to take a corrective action, or you want to do something. So in that case, exception management. Then deadlines, escalations, notifications, and other required features that may require human intervention within a process. Almost all business cases are human flows. Yes, most of them. Yes. At some point or the other, a human intervention is required. That's right. Yes, all processes usually require human intervention at some point or the other. So human workflow is a very critical element in business process execution. Then organizing, filtering, prioritization, other features required for end users to productively means basically, let's say your manager, and the manager has 2 guys who are reporting to, no, not the manager. Let's take a CEO. The CEO is responsible for everything in the company. So it does not mean he gets involved, personally in everything. There are a lot of people reporting to him. There is a chief operating officer for operations. Then there is HR for HR related stuff. Then there is a finance head for finances. Then there are a marketing head for marketing. So the CEO simply delegates activities to all the guys. Now that can be performed using a human workflow application. The human workflow application can be integrated into a composite. So that way it can filter, organize, prioritize, all that stuff. You don't really have to worry about these things, but these are some of the features. Reports, reassignments, load balancing, other features required by supervisors and business owners to manage performance of tasks. Basically, distribution of the load, the last thing. This is one of the examples of human workflow. A BPL process here is calling a human workflow on the right side. So the BPL process has to get approval so that it can move forward. Now to get the approval, you have a human workflow element. The human workflow element, one person to another person, there can be a delegation, there can be a group of people. All right, another group of people is mapped to one. The human workflow itself provides a lot of patterns. So the BPL simply asks for approvals. If every day morning the manager logs in and approves it, once the approval is given, the BPL process can move forward. So if you have seen this entire discussion, a BPL process might take days to complete. Remember that. So it's not like you send a request, you are getting a response. Not like I'm opening a URL here with make my trip and I'm getting a response immediately. SOA request response does not work that way. An SOA process might run for days. For example, the eBay that I have taken, from the point you purchase the item, that's when the process starts, a BPL process. All right, let's go back to that diagram. It's really important that you have all those. This is a different style of thinking, so it's important that you use that style. So here I am talking about a process which executes this flow. Calls the order management service first, then calls the delivery module, then calls the tracking module, feedback module. Now this entire thing will happen over days, from the point where a customer purchases something till the point the customer gives a feedback. This process is running for days. So it's not like you send a request, you get a response. Not that style of process execution we are talking. We are talking about a process that needs to be live on your system for days. That's where your database comes into picture. How do you keep a process live for days? You basically store it in a database. We'll come back to that part later. So, but the most important thing, the differentiator that we normally are working and what you will be working in SOA is, SOA process may be going on for days. Whereas a normal request response style, it either happens or it fails. SOA does not work like that. All SOA BPL process, they may go over days. Alright, let's come back. Now the human workflow, one example we have seen. Alright, then there's another example here. Example 2, the same thing. Another BPL process invokes a workflow service here. Alright. The workflow service again can send the notification through a user application. The user may approve it, or another user application, or the workflow service can send out a notification. Nowadays sometimes you will see send Y if you say okay, or send N if you say you're not okay with that kind of stuff. Alright, you can send SMSs, emails. The workflow process can still means approval. We always see that, right? Approval need not be always through a browser. If your CEO is traveling and if your manager is traveling, you can set up a mechanism wherein the manager simply sends an SMS with Y, and the workflow service should take it as approved and send response to the BPL process, and BPL process can continue. That can be implemented. This is another example. Internals of human workflow. There is a service interface. There is a client interface. The client interface is what we've been talking about. It can be a SMS or phone-based interface. It can be an email-based interface, or it can be a regular portal wherein they log in and they approve, or a BPM work list application, business process management. This is a custom work list application. We will see this BPM work list application. Then inside the human task flow, you have roles, users, groups, who falls into that group, all that. That's not really our part. Somebody else will manage it. and all those roles, users, usernames can be actually imported from an external LDAP. For example, the email system that we have, that can be integrated with SOA, so that all the employees of the company actually form the users of our SOA system. Now these are just examples. Now the next element, the fourth element. So we got the first element, BPEL, process manager, second element, mediator, third element, human workflow. This is the fourth element, decision services and business rules. I've already given you an example, a very good example here. These are the rules. The rules are used by the decision service to make a decision. And the decision service is actually called by a mediator to give a decision. So that depending on the decision, it can route a request. Very intricate. So here BPEL or mediator will call the decision service. It can call decision service 1, it can call decision service 2. The decision services actually uses the business repository. Business repository is where you have all the business rules stored. Alright, now the rules can be defined using a lot of tools. This is one tool, Eclipse, rule project management tool. There's another tool, rules authoring tool. Any of these tools can be used to actually change the rules in the repository. Now the decision service executes all these rules and makes a decision in the rules engine. There is an engine called rules engine. I think we have seen in the list of engines here. Where is that? Go to that. Go back to that main diagram. This is the heart of everything. SOA. This one. So in the engine, you will see rules engine. The reason we have listed the engine here is each engine executes the corresponding type of component. So BPEL engine executes the BPEL component. Mediator engine executes the mediator component. Human workflow engine executes the human workflow component. Rules engine executes the rules component. Alright. Components are what is the code. The code has to be executed in the engine. These components together form a composite. Alright, so components are internals. Composite is a total bundle. The internal components get executed in the engines. Alright, in any of these engines, it may call an external service, an external software through an adapter. Alright. Now let's go back. So I'm going back and forth. I'm really sorry about it. Alright. Now the last element, the last component of SOA, the Spring context. Spring context basically it enables a Java application inside a BPEL or mediator. Java inside XML. That's a proper way of putting it. More than this, you don't really need to know anything about it. This is more a developer stuff. Alright. Now if you are a developer, now all these things that we've talked about so far more from an admin's perspective. If you are a developer, alright, you will come across the next set of words and you need to know a little bit about them also as an administrator, just for the definitions at least. You will come across a word called UDDI. It's called Universal Description Discovery Integration. It's basically how a service gets discovered. Now if you take the example of this thing, we have a service called BPEL process for business travel. What this service is giving? This service is providing the best ticket, return the best offer. That's what this provides. It returns the best offer. So if somebody has to call this service, even though we are saying the BPEL process, this is exposed to the outside world as a service. Now the service, if somebody has to call, they first have to know where the service is available. So it's like listing in the, let's say you have a business, you list it on the just dial. Now the just dial is the UDDI we are talking about. All the services register themselves on the UDDI so that they can be discovered by anybody who is looking for the service. So UDDI is the just dial in our case. Then WSDL. WSDL is how you call the service. Means, okay, you have found out that there is a service called BPL process service, which actually returns the best offer. But how do we know what kind of inputs need to be sent to this process? The inputs to this process are actually the source and the destination that the client supposed to know, or instead of the client supposed to know, the BPL or the service provider itself in this case will define it in what is called a WSDL, Web Services Definition Language. That's what a WSDL is. It's called usually WSDL, WISDIL, WSDL or WSDEL, anything you can call it. A WSDL, Web Services Definition Language, is again for developers perspective. What it does is it tells how input to a service should be sent. So the WSDL of our BPL process says that I need two inputs, source and destination. So the client knows that in the request it has to send a source, it has to send a destination. And the third thing, XSDs, XML schema definition. The XML schema definition, it basically tells how an XML file should be written. If you see our WebLogic config.xml file, all of us are working on XML. This is a cloud server, so I'll give you details of the cloud server today. So let's say I'm going into one of previous batches, domain home, P10G, user projects, domains, encode DMN. This is one of the domains of my previous sessions. Now let's go into config. If you open the config.xml file, see this one, or let me open it in VI. That will be much more colorful. Don't open it in VI unless you really need it. It will corrupt the config.xml. So if you look at this thing, the first line basically tells a list of XSDs. See, security.xsd file, xacml.xsd file. These are the schema definitions. What they do is they will tell how the config.xml should be written, the rules that the config.xml should follow. If it does not follow certain rules and you randomly write a config.xml, when you are starting the start weblogic.sh, the start weblogic.sh cannot process this information. It's important that you follow the rules, and the rules are defined in the schema definitions. Alright, that's XSDs. You don't have to worry about the XSDs, but that's what it actually is. It's important that you know the basic stuff. So now all this time we've been talking about web services. For a normal browser, you're sending a HTTP request, alright, and the page that you're looking at is defined in HTML. So browser sends a HTTP request, the Gmail responds to that HTTP request. So the protocol you are using is HTTP and the language you are using is HTML. So browser understands the HTML language and gives you a nice presentable form. If the actual HTML itself you want to see, this is the HTML. This is the code that's written. Probably similar to that one. This is pretty dynamic code. So static code would pretty much look the same way. Alright. Or if you take our website, take for example source code. This is the HTML. The HTML is processed by the browser. It is shown to you like this. And the communication between my browser and the encode.it.in website is happening through the HTTP protocol. The same way, If I have to call a web service, I need a protocol to send my data over the network, and I need a language, HTML language kind of thing, alright, to define the structure like this. The HTML defines that there is a head that basically says the title of the page, then there are meta tags, there are titles, then there are, it says if there is a table, it's a table, if it is a script, it's defined as script. So these are all tags, and the browser knows about these tags. The same way, if you're now in this case we are talking to a web server, probably the encode IT web server we are talking about to. From browser we are talking to a encode IT web server, and we are using the HTTP protocol to transport the content and HTML language to define the structure of the content. Now the same thing here. When it comes to web services, SOAP is what defines the content. Means SOAP is like HTML. SOAP again uses HTTP to transport it. Is it the correlation? SOAP is the HTML of the browser. SOAP corresponds to HTML. But HTML is if you are talking between a browser and a web server, whereas SOAP is if you are talking to a service. Then the HTTP protocol is pretty same. So for transportation we use HTTP. For content definition we define SOAP. So you always say SOAP over HTTP. That's how web services communicate. SOAP is the content, HTTP is the transport protocol. Alright, see this one here. SOAP just tells about the format of the message, and more importantly how it should be processed. SOAP does not tell how it should be transported. SOAP uses HTTP and SMTP protocol to establish connection and message transmission between web service. So basically for transport we're going to use HTTP or SMTP. And again SOAP internally uses XML for defining the structure. This is one of the examples of SOAP message structure. So it basically gives you a header, where it's going, how it's getting there, the transport part, and then the content part. He is the one who is calling the service, the provider is the one which is providing the service, and the web service is exposed outside using a WSDL. The WSDL tells what are the inputs required. This is the code for SOAP message. So the developer would be writing this code. Basically the top part tells you, the transport part using HTTP. The bottom layer basically tells you how to process the content, what's the structure of the content, all the stuff. So this is a client calling a web service. Again there is a client, a lab view. This is probably an application which is a .NET application. The .NET application uses a SOAP message, transport it over the HTTP protocol across internet, and it calls a web service which is available here, the triangle. Alright. So web service is provided by the triangle here, and the client who is calling the web service is the .NET assembly application. Similar stuff again here. This is SOAP client on the left side, sitting at home, back office. A web service is what is offering the service. You send a SOAP request, you get a SOAP response. Alright, the transport is happening over HTTP. This is another example again. Alright, I'll just you will just go through it. This one, this is a slight difference. UDDI, WSDL, SOAP, HTTP, the relationship between these four. Client calls the UDDI here. The broker is nothing but the UDDI. When it calls the UDDI, it knows about the provider information, where the provider is. A client can call the provider, get the WSDL, means the WSDL tells what kind of inputs should be sent to the provider. Then the client sends a SOAP request with all the required inputs. The provider responds with the response, with whatever output. So UDDI is the registry, WSDL is what tells the inputs SOAP is the request format, HTTP is the transport protocol. The same again in another format here. This is a calling service, this is a service provider. So there is a service requester on the left side, service provider on the right side. Alright, the requester first queries the service broker, which is the UDDI. When it queries the service broker, it gets the WSDL, the definition. So now the requester knows what kind of inputs need to be sent to the provider. With all those inputs, the requester sends a SOAP request to the service provider. The service provider responds with a SOAP again. This is a communication between a requester and a provider using WSDL. Now UDDI is not available in SOA by itself. Just remember that. UDDI can be an external agent. So all the services offered by SOA can be published to a just dial. So just because we are listing it on just dial, it does not mean your office is in just dial office. It is just a listing. The same thing, UDDI is a listing. This is another example, and a much descriptive example. Now, what is the endpoint in a web service? Endpoint is what we say, that's where your request should go to. Means the URI of the service. Means you should send your request to that URL. That's an endpoint. So every service has a WSDL which defines the inputs, and it has an endpoint where you should send the request. Alright, cool. So here again, now this is SOAP uses XML syntax but not HTML. That's right. SOAP uses XML syntax. That's correct. Sorry, I've typed it a lot of times here. Yeah, SOAP uses XML. It's not HTML syntax. Now here again, the same stuff that we've been talking about. The requester is the one on the right side. The provider is on the left side. There is a slight, the image is in a different way. The requester first asks, see this question here, where can I find a service? Now the web service basically said, look at the UDDI. So the UDDI register was looked up. Then the requester found the service. Once it found the service, the requester is asking, what do you do? Now when you ask what do you do, or how to send a request, the web service is saying, don't ask me, ask the WSDL. So WSDL basically tells about the inputs that need to be sent out, the outputs that you can expect, all that stuff. It defines a web service. It's called a contract usually. You will come across this word also. WSDL defines the contract. What's a contract? A contract is the terms and conditions. What am I going to give you? What are you going to give me back? So that's for a contract for a web service is defined on a WSDL. So WSDL defines a contract of a web service. The contract defines what inputs need to be given, what outputs can be expected. Alright, now we're actually getting into the composites part. So if we've been working on WebLogic so all this time, so we know what a Java application would look like on a WebLogic console. So we are actually given var files, er files, rar files. We deploy them to WebLogic. So if we all know their Java applications are deployed on WebLogic, WebSphere, JBoss, and Tomcat. These are the application servers where the Java applications run, and all of them are actually developed using Eclipse tool or JDeveloper or NetBeans. There's a video here that shows you how a Java application code would look like. On the right side, we are talking about SOA application. SOA application is not called JEA, it's called a composite. A composite can have one of the 5 components that we talked about. Is Java providing web services different from Java web services? No, it's same. Java web services are nothing but your, the people implementations. So all our developers actually learn web services part also. The Java web services is nothing but your, people. It uses people at least, not completely, but it uses. They are same. So here, for a SOA application, we call it a composite. It's usually developed in BPEL. Alright. The tools to develop that one is again JDeveloper. I'm going to show you a video. So the main difference between a Java application development and a composite application development, composite is more like a drag and drop stuff. That's why a lot of SOA developers, now the reason why SOA development is so popular nowadays is it's drag and drop. You don't have to know anything about Java to actually develop a composite. So I'll show you a video, you will get a better view of it. So I'm going to show you first a Java application being developed, then I'll show you a video of how a composite or SOA based application gets developed. So this is a Java application. I just picked it up from he's talking about, if you say this is Eclipse, the interface you are looking at is popular open source it's like more like you write the code, that's it, it's raw code that gets developed. Alright, so, your tool, Eclipse tool, will assist you in corrections. See, he's right clicking and getting corrections to that stuff, and then towards the end debugging it at this point, and usually it gets converted into a jar file also. Jar file or AR file. The AR file or AR file is usually going to so we'll AR file CR. Then we go ahead with our regular Java application. Now, as opposed to a Java application, if you are a SOA application or a composite developer, this is what you will be working on. This is what our developers are working on. Yeah, this is the JDeveloper interface you are looking at. That's right, Kalyan. We can deploy jars. Actually, jars, they are composites, but still they will be bundled as jars. So the extension does not really matter. What is the inside matters. Inside a WebLogic file, the application, you have Java code. Inside a composite, you have BPEL code, and this is BPEL code you are looking at on the screen. This is the JDeveloper interface. Earlier you have looked at Eclipse interface. Now all these things are really important, guys, so we may not be directly using them, but it's important that you have an overall view of how things work around, so so that when you're troubleshooting, when you want to do something, it will be easy. It's a little boring, but stay with me. We'll be getting into much more interesting stuff as we process. See here, just on that screen that we're seeing, if you observe, look at this one: composite with a BPEL process, composite with business rule, composite with mediator, composite with human task, composite with Spring context. These are the components, and when you insert one of these components, you are creating a composite. So a jar file that's given to you may have a lot of such components, and when a developer is developing, he has got templates. He simply selects such a template. When he selects such a template, see what's happening on the next screen. This is an empty composite, and now it did not select anything. Then XSDs are being selected. I'll upload this video also, so have a look at it leisurely. You don't have to understand anything in depth, but it's really important that you know what this guy is trying to do. is importing a schema XSD, and to that schema, this is the graphical representation of that schema. The XSD says how the employee ID, the name, the salary, they have to be defined. Okay, that's pretty much another. Let's go ahead. Now he is connecting a adapter. Using an adapter. The adapter has to be installed by us, the administrator. So the composite is looking for an adapter. The adapter, after we deploy or before we deploy this composite, we have to configure a database adapter. On the right side, if you see, these are various service components you can drag and drop. You got B process, business rules, task flow, and you got a database adapter here. You got a file adapter. We'll be talking about some adapters during our adapter session. So some more, if I go forward, I'm just forwarding. See this one, drag and drop stuff. This is all. This is a BPL process. This is how it looks like. Just like a flowchart that we've seen. You click on each of those elements, you configure the properties. See this one here. You are invoking something, you drag and drop it. Read the employee record. Easy stuff. Software development, I heard is pretty easy to learn. That's very nice. Alright, so you will go through it. Alright. When I give you that video, basically, sir. Alright, so okay, that's your videos. Alright, so we have seen both what we have seen is both a Java application versus a composite. Composite is more like drag and drop. You get everything in XML. So inside a composite, remember these words. We are talking about a composite which you will get from a developer. The composite internally will have the components. We'll talk in depth into these things. Components are the 5 things that we talked about. BPL component, mediator, human workflow, decision services, business rules, and Spring context. Alright. Then this is the composite we are talking about. Oracle Source Suite is a group of Java variant. Now, okay. Now instead of a composite, what we are saying is, what is Oracle SOS Suite? As I was telling you, Oracle Source Suite provides you the engines. I'm saying, right? In what language those engines are written? They're all written in Java. So that's the reason what we usually do is you install a blank WebLogic. On top of the blank WebLogic, you have about 60-70 applications written in Java. Those applications together will form the SOA, and those applications are nothing but your engines. Alright, now if you have to look at those applications, these are those applications, some of those applications. See this one. I went into SOA domain. Let me actually go in there. I'm going to start one of my old SOA domains, then log into the admin console. I'm starting the admin server. We will be doing all these things in our couple of sessions from now. This is one of our SOA domain admin server.
Is that a custom script that you're writing?
Yeah, that's a wrapper script. We'll talk about the wrapper scripts also. Internally, it has the start weblogic.sh. It starts the server and then it opens the log in tail-f. So this is my SOA server, SOA domains admin server coming up. Look at this one. This server is running on 192.168.128.6 7001. That's the admin IP port. So I'm going to log into the console. Riaz, is that you? Can you put yourself on mute, Riaz? SYA admin is a username. SYA admin 123 is the password. Thank you. So this is the username password for this domain. SYA. I'm going to SOA applications. When I say SOA, it's nothing but a big group of Java applications. See this one. This is the screenshot that I've shown you. These are the applications. Java applications will form your SOA. So SOA is a large Java application. The Java application, what it is doing, it's providing you the ability to run the components. When I say BPEL engine, it's a Java program. So when I say mediator engine, it's a Java program. What the engine does, it executes the composite, which is written in XML. Alright, so the underlying technology is still Java, means the entire SOA is in Java, written in Java. But what SOA does, it allows you to expose something as a service, and it does it in the XML. So these are the various applications which are inbuilt. Means the moment we create a SOA domain, these 71, 81 applications that you are looking at, they are already available. They are inbuilt. We will see those things, when we create an SOA domain. All right. So here, coming back, so SOA is a large group of basically Java applications. Then there are vars, nars, they're all engines. All right. Then these engines allow the composites. The composites are written in BPEL. So you can run the BPEL execution language related composites on these engines. And BPEL is actually the XML which internally uses, and I'm using GDeveloper. Just now we have seen. This is a screenshot that I've just now shown you. Alright. That's your fundamentals. Now we're going to move ahead into installation. These are our installation steps going to be. BPEL apps are also vars, ERs, jars. Not ERs, jars, only jars. Not vars and ERs, only jars. All BPEL applications will be given to us as jar files. And you may get a group of jar files as a zip file also, which is called a SAR file. So a composite is usually in a jar. So developers bundle everything into a jar and give it to us. Now here, let's come to the installation. The installation is slightly stepwise. You need to install the MDS first, or you can install the MDS towards the end also. The first thing is you're going to install a JDK, which is required by WebLogic. So after the JDK is installed, you will install the WebLogic. After WebLogic installed, you will install the Oracle SOA suite on it. Once Oracle SOA suite is installed, you can actually create an MDS and create a domain that will connect to that MDS. So we'll be doing all these things step by step. The arrow mark you are looking at, they can be executed towards the end. Means First install JDK WebLogic source suite, and then install MDS, and then SOA domain. That can be done. Or not, what people normally do is they install the MDS first, then do all these things at a time. Either way you can do it, but the three boxes you are looking at, JDK box, WebLogic,
Welcome
Oracle.
to DAY02 meeting. Not.
So your JDK, WebLogic, Oracle source suite, they don't require MDS. MDS is required by the domain. As I told you, Oracle SOS suite is nothing but a large group of Java applications. Those Java applications are actually being put onto WebLogic, WebSphere, or JBoss. Oracle SOA is supported by these three application servers. So you may see Oracle 11g source suite deployed to WebSphere also sometimes. So Oracle does not mandate that you have to always use WebLogic if you are using their SOA product. You can use Oracle SOA suite. You can use any app servers, any of these three. The same way the database also. You can use 3 or 4 databases actually. The 4 databases are from 4 of the big companies: Oracle, IBM DB2, Microsoft MS SQL Server, and then there is a open source MySQL. These 4 databases. So they made it look like it's a generic product, but the recommendation is always SOS suite with WebLogic. Alright, so we'll be working on the installation in our tomorrow's session. So make sure you don't miss it. The database is already installed here. Alright, so the database is actually running on our cloud server. I'll give you all the details of the cloud server, how to log into the cloud server, and how to start the database, shut down the database, all that stuff in tomorrow's session. Alright, once we are done with installation. All the files, installation files, everything is available on the cloud server itself here. Right under home and code IT, you will find a directory, SOA install files. All files are available here itself. Alright, your SOA files, your OHS files related, then there is a RCU related stuff, the JDK that we're going to install, the WebLogic 10.3.6 that we're going to install. Everything is available pretty much here. Means you just have to connect, start practicing. You don't have to download anything at all. Now this you're going to use initially till you set up your own environment. Your own environment, I'll give you a clone. The clone is like this. Alright, you will be given a 40 or 50 GB file actually. Alright, so if you see this one, you will have to be using Oracle VM VirtualBox, this one. This is a virtual machine software. Alright, and this is the clone that you will be given. This is actually a Linux machine inside a Windows machine. So this Linux machine has all the softwares again, just like our cloud server. So this is a Oracle Enterprise Linux 6. Alright, this box will be given to you. This box has a size of 40 GB. Alright, it's expandable kind of, so the 40 GB you have to download on your system, and this is the file you would get usually after the download. This one, OEL, this is about 40 GB, and this file is what we're looking at, Oracle VM VirtualBox. This is the software. Alright, this is software to run the virtual machines. So for your at-home practice, require at least 8 GB of RAM for SOA practice. So this virtual itself takes heavy memory, because you will be running a database inside the virtual box, and you will be running all the Oracle servers also. Now in our lab environment here, the way we are practicing, we will actually initially we will be doing everything on a single box. Later we will move into a multi-box environment. Means the database will go to a different box, then all our WebLogic servers will be on a different box, and this is going to be our architecture. So if you let me show you that. Yeah, if you see, this is the installation document. This is what we'll be following tomorrow. Like RAM, you need at least 50 GB hard disk you will need for all the installation and required files. And these are the steps we're going to follow. Alright, this is the domain structure we will be installing. There will be one admin server, two managed servers, SOA and BAN. We'll talk about those things. And this will be actually on two boxes. So on box 1, yeah, I did not give this one. Yeah. On box 1, you have all our servers, alright, especially the 3 servers initially. Once we have a cluster, we will have more servers, but initially we'll have only 3. One admin, two managed servers. One of them is SOA, one of them is BAM. We'll talk about BAM later. And our database will be a different box later, and the database will hold the MDS required for this domain. Alright. Server 10 is the cloud server you are looking at. This is the server 10. Alright. Yeah, this is where our initial practice will go on. Later, we will move our database, or actually the database is on a different box also. So we'll set up a separate environment to connect to that database. Otherwise, this box gets heavily loaded, because you will be running database and then you will be running 4 or 5 servers, which you cannot do at a time. Alright, that's our initial setup. Any questions today? All today's content is more towards the generalities, means how your environment would look like, what are the developers doing, what is that you get from a developer. It's really important that you know. So you got a clear idea of what you will get from the developers, how they do the development, what are the components of a composite that you would get, how a composite is different from a Java application. That's really important. Once you understand that distinction, then everything will be much clearer. So we are actually working about how to access encode IT. I'll give you that IP port numbers, everything, a username, password, all the details. Vamshi, I'll give you all those details in a mail, and the process to access the servers. Okay, any other questions? I'll be sending the PPT, and we'll be uploading the video also in about 10 minutes. So about 30 minutes, let's say. You can download the video and the PPT in about 30 minutes from now. Any other questions? That's all we have for today. If you don't have any questions, you can disconnect. If you have any questions, shoot. Thanks very much. I'll see you tomorrow, same time, 5:45 sharp.
Hello?
Yes, Mukund, go ahead.
Hi, sir. This is Kalyan, sir. I
Yes.
have a doubt, how these engines, like people engines and beta engines, will help, the jar files which will be compiled, and the jar files, how, if they are deployed to SOA domain, like JVM, how will that help in like servicing the requests? I'm not getting the point.
We are defining our process in BPEL, right? So
Yes, sir.
we are putting everything in XML. Now the XML is basically you are sending a request and you are expecting a response. Now the engine has to process that request, isn't it?
Okay.
The engine has to process that request, but for the engine to process a request, it has to go to a machine level. A machine level programming languages, we have only C, you got Java, you got .NET, which can actually talk to the CPU. If you take Java, for example, it talks through a JVM to the CPU. So even though I'm defining something in XML, I need somebody who can actually talk to CPU, isn't it?
Yes, sir. Yeah.
So that's where my engine comes into picture. So my engine takes the XMLs, alright, gives it to a Java program, which in turn is capable of talking to a CPU through a JVM. Finally, I have to reach the CPU.
Okay.
That's where my things get executed, and I need somebody who talks to CPU. And only programming languages can talk to CPU because they will have the compilers inside. So what we have is, I can use, I'm using here in this case a Java which can talk to CPU to process
Okay.
my XML inputs that I am giving.
Okay.
So BPEL is, it's business easy type. That's the reason we are using XML. Means it sounds more like we are talking in terms of the way business is done instead
Okay. So
of
how Java language?
talking like.
So how this Java language can interpret the XML language and it takes it to a CPU to JVM?
What is XML? You have to just strip off the content, right? If you see XML, let me show you that SOAP message. This SOAP message is given to a Java
Yes.
program. I have stripped everything else, and finally what I got, stock name is IBM. I had to get the stock price,
Okay.
isn't it? I just strip off everything else.
Yes.
In this entire SOAP message, all that I need is the name of the IBM. So if you have written a Java program which takes the input as the name of the stock IBM, can it return the price of that stock?
Yes.
Can a Java? The same thing it's doing here. Only thing is we are doing it in XML. It's easy for us.
Okay. Okay.
It takes a stock name and returns the value. In Java program, basically the engine, it strips off the entire unnecessary part. So it's easy for us, for a human being, it's easy to process this way rather than like, talking like a machine. That's why we use this. Simple.
Okay. Okay. Yes, sir. Got it. Yeah. Thanks.
Yeah. Okay. Cool. Any other questions, guys? Mukund, you are asking a question.
Yeah, then, actually, this was outside play session. Actually, we are deploying we are deploying code to a clustered environment. So in there, we also we specify the config plan, right?
Right. Yeah, you can specify the config
so
plan
in the
if you
config-
have. Otherwise, yeah.
Yeah. So in the config plan, we are specifying the host name port, the SUA port, and stuff.
Right.
In our clustered environment, there will be two servers.
Right.
For example, if
Right.
there are two hosts. So how will we specify that in the config plan?
You don't specify. You
because,
deploy to only
in
one
our
server,
modern-
it deploys. No, you don't have to
But
specify cluster service. You can deploy it to any of the server infra. It automatically gets deployed to other one. That's what the coherence is doing. Normally, even if you go to enterprise manager and just deploy to one of the server infra, it gets automatically deployed to the second one. So in the configuration plan, you don't have to worry about which server you are deploying to in a cluster. Just give any of those two server IP ports. It gets deployed to that one first, and the coherent which you have configured will send it to the other server infra also. So in the config plan, only one IP port. That's enough. The server cluster will take care of the rest of things for you.
okay.
Okay, any other questions, guys? If you don't have questions, you can disconnect. Or yeah, you can stay to just to listen to the answers. That's fine. What time is the class tomorrow? Same time. Same time, 5:45 IST. 5:45 IST.
Uh, it may be a very big question. What exactly is SUA infra?
So infra is the infrastructure that we are talking about. Now if you go into, let's say, console that I opened, alright. The entire infrastructure is usually called SOA. This is the enterprise manager.
Because we were uploading to MDS, and since
Yes.
SOA infra was down, it failed.
No, I cannot actually hear your voice. SOA infra, because we did not start the SOA server. SOA infra is what you will get. One server with all its engines. EDN is SOA infra. You will see SOA infra for each of the servers. And you were asking some other question. Your voice is breaking.
My okay. So the reason I asked was basically because we were deploying our code on MDS, and the MDS upload failed basically for the reason that the SOA infra was down. I checked the deployments, and it was in a failed state. But I was not sure what SOA infra is. That's the reason I was asking.
SOA infra is basically your SOA server. SOA server. It is complaining that SOA server is down. SOA infra is nothing but SOA server. Each SOA server represents one SOA infrastructure. So in a cluster, you have at least two SOA infrastructures. So when SOA infra is down, it means the server is down. It's not able to reach the server.
Okay.
So you need to check whether the server is actually down, or you are giving a wrong IP port, or something in while the SOA server is coming up failed. So it's possible your SOA server might be in running state, but there are a lot of errors when it came up. Even then, it will the deployments will fail. So go to the log file during the startup. Check if there are any internal errors when the SOA server is coming up. Make sure there are no errors while it comes up. That's a very common problem, especially when your SOA server is coming up. Yeah. Any other questions, guys? Otherwise, you can disconnect.